Good afternoon. My name is Alexandra Kolossov, and I'm the SVP of Crypturns, one of our sponsors for this amazing event. Thank you, Your Highness and Your Excellencies, for organizing this and showcasing all these innovational minds. Now, I want to start off with saying, for over the past 60 years, aviation has been the portal into space. We have engineered innovational spacecrafts, yet the question is, how is this impacting climate change? And what can we do about it? To discuss, I welcome Leonardo and Tudor, and unfortunately one of our panelists, Sikur, could not make it today. However, he will be in our minds and thoughts. So welcome. Leonardo, Tudor, welcome. I would like to start off maybe hearing a little bit about yourself, if you don't mind.
Okay, thank you very much for the introduction. I'm Leonardo, the space pianist. You saw the pianist part. Now I'm really honored and happy to talk about the space part. So I am an aerospace engineer, senior lecturer at the Malta College for Art, Science and Technologies, senior lecturer in aerospace engineering. And I represent MCAST and its aerospace program, where there are ongoing projects about topics that will be soon discussed, and also the related master in aerospace engineering. My field of expertise is in technologies and measurement for aerospace, and in particular about space debris and impacts that can happen in orbit, but also this is scaled to the aviation field. So this in a nutshell my main activities as an engineer.
Fantastic. In a nutshell, that is.
Sorry?
In a nutshell, that is.
Yes, in a nutshell, yes.
Thank you. Tudor?
Thank you. So I'm Tudor. As an initial background, I was actually an electrical engineer, and my main industry used to be blockchain, in fact. I started a couple of startups in the industry which went pretty well, and then I decided to join the space industry, initially as an investor and then eventually as a much more involved party. So now the main company I'm working on is called Voidship, which is building small launchers for nano and micro satellites. We are building a rocket which is powered by Metalox engines, which are very, friendly for the environment, which is also what we're talking about today. And in addition to that, it's also one of the cheapest available solutions on the market right now. So that's what I do pretty much, yeah.
That's amazing. So what actually got you, or what was that key moment that actually put you together from going to blockchain into space? What gave you that aha moment or that interest of people that made you think, this is a topic that really cryptocurrency or blockchain can really truly change? And then, of course, we'll go into actually, wait, we can also help the environment whilst doing this.
Absolutely. So first of all, I do think that they intersect quite a lot. And in addition to that, I do think that over time, it will just continue to intersect more and more, especially when you're talking about things like running nodes into orbit directly. As for the exact moment when I realized I want to do this, so as an early adopter of blockchain, which was probably like almost 10 years ago, it was that feeling of, being able to work in an industry that is very nascent and has a very bright future ahead. So I saw the same thing in the space industry now with the advancements of technology that we have in 3D printing technology and everything else, which now allows us to actually be able to build rockets and space technology at a more sustainable level and also at a cheaper level when compared to 10, 15 years ago. When it was simply, restricted to governments and very, very large corporations.
Interesting that you say that. And Leonardo, you talked about debris. So based on also 3D printing, how you mentioned, or renewable material for using for the spacecrafts, how do you think that will affect also debris in the space?
So space debris became in the last 15 years, at least more, but above all, in the last 15 years, a topic that seems far from our daily experience, but in reality affects us much more than we think. Why? Because since the launch of the first satellites of the Sputnik 1, we started populating the orbit around our planet, in particular the so-called LEO, low Earth orbit. And the population of inactive satellites increased, or damaged satellites, and consequently also debris and the risk of impacts, making mission risking partial failure, catastrophic failure, but also putting at risk the manned mission. So basically, as humans, we are also polluting space, at least the one around us. Currently, the development of 3D printing materials is a big challenge from a technical point of view, but also a big opportunity. Why? Because on one side, as a challenge, these materials need characterization because their behavior is not well known. Like, for example, the most common man-made structures in space are made of aluminum, which is a super well-known material nowadays. 3D printed materials are less known, so also how they fragment, how are the structural performances is still not well known because it's a super fast developing field. But at the same time, new type of design, more specific design targeting how also to limit the space debris, so with shielding, with higher performances, plus other techniques that now I don't list them all because we don't have enough time. All these techniques allow to mitigate the risk. So debris are increasing and are making the access to space more and more difficult, but these new studies allow to mitigate together. For example, another very good ways is the orbiting of satellites. So they burn, let's say, 99% in the atmosphere, so they don't stay in space.
Oh, 99%, did you say?
No, sorry. What I was meaning is a satellite re-entering, if above all, if it is small, it burns completely. If they are big satellites, so like the size of a car, there can be small fragments that arrive till the ground. So, but at least they clean the orbit where they were previously, so they don't represent a risk anymore.
So what you're saying is that they also they actually eliminate the debris.
Yes, there are active debris removal is one technique. Another one is like in low Earth orbit, above all, we were mentioning before, small satellites. For example, there are a lot of CubeSat. CubeSat are a lot. They are not really a risk because they stay in orbit 1, 2, 3 years, and they re-enter the atmosphere and they burn. So are the bigger satellite the risk? So I don't know if you want to add something about satellites.
Sure. So to build upon what my friend is saying, the idea is that now because of the advancements of technology and so this allows us to focus on building rockets that have a very specific niche. So in this particular case, if you decide to focus on nanosatellites and microsatellites, you get several advantages. So one of the problems with pollution in general, when you talk about rockets, is that most of them actually fly half empty, right? Because they have very large loads, and so the clients want to launch this, they need to do ride sharing, and so they have to at some point just launch the rocket. But it consumes, just as much fuel as if it would have been full. So one of the advantages when you're building a smaller rocket, like up to 25 kilograms like the one we have, is that you can try to always launch it in full, or at the very least, mostly full, right? So that's the first advantage. The second one, as my friend here was saying, when the satellites are smaller, upon re-entry in the atmosphere, they actually get, in essence, obliterated. So they don't actually create more and more space debris, as opposed to larger satellites. So I would say that this is, one of the things that we can try to focus on in order to make space more sustainable, along with focusing on green fuels and along with trying to make at least partially reusable rockets. So as long as we manage to at least bring the first stage of the rockets that we launch back on Earth, then that will definitely have a very big impact long term on the sustainability of space exploration and everything that pertains to it.
So I see here actually also a fruitful relationship happening. So my last question to you, gentlemen, is coming from an industry's perspective, and then coming also from an innovational perspective too in blockchain. How do you think that the future in space and aviation industries can cooperate towards a zero emissions solution? Or what is your vision, what is your belief that what should we do to make that change happen?
So actually, I'm at MCAST, which is Malta, and so European community has strong guidelines and very huge projects regarding the topic, for example, about greener aviation. What can be done is investing in research materials, investing in more efficient engines, but also how these engines are managed is also like for the rockets. A lot is related with efficiency. So in the past, like a 747, so an historical model, had a fuel efficiency around 30%. If we take an A380 nowadays, also thanks to composite and so on, we are in the range of 45-50% about specific fuel consumption. So there are improvements. Is still not enough to really do a drastic change, but there is at least a very good plan. So this will usually there is a delta of like 15 years between research and seeing in our daily life in aviation with the results. Would I like to add something about it?
Sure. So obviously efficiency is the lowest hanging fruit and we should definitely focus on it. I would just add that beyond this, we can also focus on the types of fuels that we actually make use of. So to give an example with the engines that we have, we are using metalox, which is liquid methane with liquid oxygen. And so the cool thing about it is if you decide to extract it from biomass. So as an example, let's say we just have plants, and those plants are capable of generating methane. So we can liquefy that methane and then transform it into the fuel that we use for the actual rocket. So the end result of that is that the carbon and the soot and everything that we actually put in the atmosphere when we launch the rocket can be offset by the carbon that is absorbed by the plants that we use to actually generate the initial fuel, It can actually become carbon negative if you try hard enough and efficientize the whole process, as my panelist was saying as well.
All right, so you guys have also the challenge to make that happen for all of us. We'll be looking forward to seeing you also. And thank you so much. Thank you.
Thank you
very much
Thank
for
you
this
for having
session.
us.